Salutations, mini mathematicians. Great to see you. Today we are going to get into the 6th and 7th rule of our exponent properties, negative exponents and the power of 0. So if you want to swoop over your page or write on a different piece of paper, we just want to look at this pattern of exponents. And what we're doing today is we're going to simplify negative exponents and 0 exponents. And expressions are not simplified if there are negative exponents in that. And we've talked about this at all before. And we are going to explore 0 to the 0 power. What is that? What does it mean? So taking a look, you know that 2 to the first power is 2. Look up high. The exponent is how many times you multiply the base times itself, but it's also still always times 1. So you can think about this as 1 times 2 to the first. 2 to the second you think about as 1 times 2 times 2. 2 to the third, 1 times 2 times 2 times 2. And 2 to the fourth, 1 times 2 times 2 times 2 times 2. So 1 times 2 is 2. 1 times 2 times 2. 2 to the second is 4. 2 times 2 is 4 times 2 again is 8. And 1 times 2 times 2 times 2 times 2, or 8 times 2 is 16. Awesome. Well, that means if we take a look at 2 to the 0, this is 1 times the base 2, 0 amount of times. So what do we get? We just get 1. Any number raised to the 0 power is 1. Of course, we have to be really careful about those parentheses and what really is our base here. But then we can get into the negatives. Well, what does that mean? What does this -1 exponent mean? Well, this negative exponent means you're actually how many times you're dividing by that base. So this is still times 1. What this turns into is 1 times 1 over 2. How many times are you dividing by 2 or multiplying by 1/2? So this is 1 times 1/2 times 1/2. And this is 1 times 1/2 times 1/2 times 1/2. And this is 1 times 1/2 times 1/2 times 1/2 times 1/2. So of course, what we can think about this is 1 over 2 to the first power, which is 1/2. We can think about this as 1 over 2 to the second power, which is 1/4. We can think about this as 1 over 2 to the third power, which is 1/8. And 1 over 2 to the fourth power, which is 1/16. So when we look at negative exponents, we are still continuing this pattern, but now when we have negative exponents, you can't multiply something a negative amount of times. That's impossible. So we start thinking about, okay, opposite of multiplying is dividing, opposite of positive is negative. So this is where this notation comes from. Okay, and we'll explore this more and kind of find a slick trick for when we have negative exponents. And yeah, we'll try to rhyme, okay? So let's take a look. So the first part says circle the statements that are correct and explain our reasoning. So I want you to take a moment and explore these and which ones do you think are correct? And then you can restart the video when you are ready to go over them. Okay, let's see which ones you said were correct. When we look at 3 to the -4th, does that equal -12? No. This is not true. Remember, 3 to the -4th is equal to 1 over 3 to the 4th, which is actually 1 over 81. Remember, 4th power is just second power times second power. So 3 to the second is 9 and 3 to the second is 9. So 3 to the 4th is 81, 9 times 9. Okay, so let's take a look. 5 to the -2nd is 0.04. Well, let's see. 5 to the -2nd is 1 over 5 to the 2nd, which is 1 over 25. And 1 over 25, well, this is in the hundredths. So we want to know what is this over 100. And if you look at that, times 4, it's 4 hundredths, which that's what this is, 4 hundredths. So B is correct. So we are definitely going to circle B. The other ones that you should have circled are C, E, and F. If we take a look at C, 3 to the negative third is indeed 1 over 3 to the third, which is 1 over 27. D is incorrect because this is negative 7 all raised to the negative second power. So this is 1 over negative 7 being squared, which we know is 1 over positive 49. F is correct, 1 over 8 to the negative second. Well, you might have noticed a pattern here. So this pattern that we're seeing is if you have the negative exponent in the numerator, you take that whole power and bring it to the denominator, and the exponent becomes positive. Same thing here. This negative exponent is in the numerator. I took that whole power, I brought it to the denominator, and the exponent became positive. So our little rhyme is cross the line, change the sign of your exponent. So here, notice that negative exponent is living in the denominator. So I'm going to take that whole power, bring it to my numerator, and the exponent becomes positive. Cross the line, change the sign. So we know that is 64. And if we take a look at E, oh my gosh, you guys, we get to combine some of our rules. 4a to the negative third, this negative 3 power belongs to the 4 and to the a, so you can think about it as 4 to the negative third and a to the negative third. And you're right, cross the line, change the sign of your exponent. So, and 4 to the third is indeed 64. Probably at this point, you've started to memorize some of those powers, which is a good thing. So explain in words how to simplify an expression with a negative exponent. So let's get pretty mathy here. A to the negative n is the reciprocal of a to the positive n, and a to the n is the reciprocal of a to the negative n. And you're like, well, what does that mean? What does that mean? That means if you have a negative exponent in the numerator, bring the entire power, that means the base and the exponent, to the denominator, and the exponent becomes positive. Cool. And what we can look at here is a to the negative x power is equal to 1 over a to the x power. And of course, we want to also say 1 over a to the negative x power is equal to a to the x power. Awesome. Great job. Really nice work taking a look at almost our last exponent rule that we're going to be looking at in this module. And of course, we're going to combine all of them together. So I'd like you to look at 4 and 5. So go ahead and finish 4 and 5. Pause the video, finish 4 and 5, and we'll go over it as soon as you're ready. Okay, number 4 says, which expressions are equivalent to 2 to the negative fourth, and explain your reasoning. So number 4 here, it's B and C. If you take a look, we want to follow our order of operation. So 2 to the second is 4, 2 to the 6 is 64, 4 minus 64 is negative 60. 2 to the negative second, all to the second power. Power of a power, we multiply 2 to the negative fourth. And C, we have a quotient of powers. So 2 to the fourth over 2 to the eighth simplifies 2 to the fourth left in the denominator. 4 factors will cancel out, sorry. You have 4 left over, and 1 over 2 to the fourth is also equal to 2 to the negative fourth. And you can always think about 2 to the negative fourth is 1 over 2 to the fourth is 1 over 16, which is 625, let's see, tenths, hundredths, thousandths, 10 thousandths. Perfect. And number 5 said, is this equal? Does r to the negative third power equal negative r to the third power? No, and looking at my math, r to the negative third power is 1 over r to the third power. However, negative r to the third power, because of those parentheses, that's negative r times negative r times negative r, to get me a negative r to the third. Negative times a negative is positive, times a negative again is a negative. Nice job, mini mathematicians. Okay, so let's take a look at 6 together. Taking a look at 6, we have Claire, and Claire believes that 2 to the third times 2 to the fourth, all to the negative first power, and 1 over 2 to the 12th power are equivalent. And let's think if Claire is correct. Well, let's explore what these are equal to. So 2 to the third times 2 to the fourth, all to the negative first power. We can simplify what's inside these parentheses first. So this is a product of powers. So we have a total of 2 to the 4, 5, 6, 7th power to the negative first. So this is 2 to the negative 7th power, which we cannot leave negative exponents. So this is 1 over 2 to the 7th power. However, when we are looking at 1 over 2 to the 12th power, obviously these are not equivalent. So let's explain why or why not. So is Claire correct? Always answer the question. No. So Claire, what did she do probably? She probably multiplied her exponents instead of added them. Claire made the mistake of, what's the word for multiplying? Taking the product. Taking the product of exponents with the same base when being multiplied. When she needed to take the sum. And we can continue with our numbers, giving that numerical evidence. 2 to the third times 2 to the fourth to the negative 1 is equal to 1 over 2 to the 7th, which does not equal 1 over 2 to the 12th. Great explanation, many mathematicians. Okay, I'd love you to take a look at 7 and 8. Determine if these expressions are equivalent to each other. Don't make the same mistake Claire did. Okay, many mathematicians, let's see how we did. Which ones are equal, which ones are not equal? Well, taking a look at 7 and 8, 7 is not equal, and 8 is also not equal. So these are both not equivalent. Hopefully you answered the question. Taking a look at the work, 6t to the negative second, the only number that negative 2 belongs to, that negative 2 exponent only belongs to the t. You can think about it as 6 times t to the negative second. So that's the only power that's going to cross the line and change the sign. Where over here, because those parentheses around all of the 6t, this negative 2 exponent belongs to the 6 and to the t. So both those powers have to cross the line and change the sign of their exponent. And number 8, taking a look here, 5 thirds to the negative 3. Well, because it's equal to the reciprocal, we can think about this as 3/5 to the positive 3. Because if you had 5 to the negative third over 3 to the negative third, that's going to cross the line and change the sign. So you can think about it as taking the reciprocal of the inside and changing the exponent sign on the outside. That's how I got here. And from here, 3 to the third is 27, and 5 to the third is 125. Where over here, this exponent, negative 3, only belongs to the 5. So that's the only power that I'm going to cross the line and change the sign of my exponent. From here, 5 to the third is 125. 125 times 3 is 375. So obviously, these are not equivalent expressions. Wonderful. Let's take a look at 9 together. So we're going to look at 2 different methods to simplify, and maybe we'll get into a little bit more of how I had simplified number 8 here. So our first step must be different in each of the methods. So method 1, what I'm going to do is I am going to write to the original problem. And from here, I am going to use, I'm going to simplify what's on the inside first before I use my power of a quotient to apply that exponent of -2. So from here, I have -2 and x, and I guess I could get rid of this negative exponent if I wanted to. So what I can do here is I'm going to bring that negative x to the -2 to the denominator, and it becomes positive. I have x to the first over y to the third, all to the -2 power. From here, I'm going to simplify product of powers. I have y to the third over x to the third, all to the -2 power. From here, a power of a quotient, I end up with y to the third times -2 over x to the third times -2. Gives me y to the -6 and x to the -6. Now I need to cross the line and change the sign so I don't have negative exponents. Now I have my final answer of x to the 6 over y to the 6. So my second method, instead of simplifying on the inside, I'm going to deal with the negative exponent on the outside. So I have x to the -2, y to the third, all over x, all to the -2 power. So like I was talking about in number 8, what we can do is we can take the reciprocal of what's on the inside and change the exponent sign on the outside. So from here, we will have x now in my numerator, x to the -2, y to the third, and now my exponent on the outside is going to be turned into a positive. From here, you have some choices. You can simplify what's on the inside or apply that power of a quotient. I'm going to simplify what's on the inside, especially because we already looked at that. Bringing x to the -2 to the numerator, or you can think I have 1 minus -2, and 1 minus -2 is going to get me 3. I'm thinking about where is the bigger exponent in the numerator, so I'm going to have x to the third in the numerator, all to the second power. So again, thinking about that, what I did is I thought about this as x to the first over x to the -2. And we know that a quotient of powers, we have one factor and we have -2 factors. Who's the bigger exponent? 1. So this is going to end up being x to the first minus -2. And -2 turns into x to the third, all in the numerator. So you can think about it that way. And here, I'm not quite done. Power of a quotient, this is x to the third times 2, y to the 3 times 2 power, so I still get x to the 6 over y to the 6 power. So something we want to note here with these examples is if you have a fraction, we could call it a quotient, all raised to a negative exponent, you can take the reciprocal of the fraction and the exponent on the outside changes sign. Changes its sign. Do you know its, possessive its, doesn't have a apostrophe like its sign because its is it is? It's one of those weird like rules, weird English rules. Okay, hey, we're in math class. Let's keep going. Okay, so we have some practice. We're going to apply our new fun rules. So I'm going to help you out. I'm going to help you out with 12, 15, 17, 18, and then I'm going to let you go and finish 10 through 19. So let's take a look at number 12. And sometimes remember, if you run out of room to show your work, don't squish it up. That's how we make mistakes. You can always grab a separate piece of paper and you can be like, oh, I don't have enough room for number 12. And you can just rewrite the original problem. And then you can be like, oh my gosh, I have a negative exponent in my denominator. I'm going to take that whole power, bring it to my numerator, cross the line, change the sign. And that's how you get a to the 5th over 1, which is just a to the 5th power. And you can always write your answer here, and you can say like C work attached. So that you know, hey, there's some work you'd want to see on your separate piece of paper. Okay. Obviously, I didn't really need to see work attached because I had enough room, but I just wanted to show you in case of future. So let's keep looking. Okay, 15. Remember, something that's helpful to do is break these into their own fractions. So I'm going to think about this as 8 over 4, a to the negative 2nd over 1, and 1 over b to the negative 3. So now I can simplify completely. So 8 over 4 is 2 over 1. I'm going to take this negative exponent only belongs to the a, so cross the line, change the sign of your exponent. And this negative exponent only belongs to the b, so I'm going to cross the line with my power, and my exponent's going to become positive. So I can get my final answer. In the numerator, we're going to have 2b to the 3rd, and in my denominator, I'm going to have a to the 2nd power. Perfect. Good job. And to put this into a computer, like a dot or something like that, we would do 2b caret to the 3rd, and then put our fraction bar, and then put a caret to the 2nd. Oops, I guess that would be down here to the 2nd. Perfect. And that's how you put your answer. Okay, so taking a look at 18, notice here we have a negative exponent in the numerator, so it belongs to this whole entire power. So I'm going to bring that whole power to the denominator, and just the exponent on the outside is going to change its sign. So from here, I'm just going to have 1 up in the numerator, and I'm going to have 5p still to the negative 2nd, but now it's to the positive 2, times 2p to the 3rd all to the 2nd power. So again, maybe you did this step here, and that's fine. Sometimes I try not to do too many steps at once so I don't make a silly mistake, and it's a little more efficient to check my work. So now this is going to be 1 over 5 to the 2nd is 25. P to the negative 2nd to the 2nd is p to the negative 4th. 2 to the 2nd is 4. And p to the 3rd to the 2nd is power of a power, p to the 6. From here, what you can do if you need to is rewrite it. So 25 times 4. And I could move this p to the negative 4 to the numerator to make it a positive power, but I'm noticing that I also have a p to the 6 here. When you're multiplying with the same base, what do you do with your exponents? That's right, you add them. So I'm going to have 1 over 100. And what am I going to do with these exponents? I'm going to take the total. How many total factors of p would I have in my denominator? Negative 4 plus 6 is positive 2, so p to the 2nd. So this is your answer. And again, putting that into like a dot or a test, I'd say 1 over 100, and I'd put a p and then a caret for exponent to the 2nd power. Nice. Okay, let's look at 17 together, and then I'll let you finish through 19. Okay, so taking a look at 17, I have this negative exponent on the outside, so I could take the reciprocal of everything on the inside first to make the exponent positive. I think I'm going to do that. So thinking about this all over 1. So now it turns into 1 over 3x to the negative 2nd n all to the positive 3. So remember, the only item that's going to change the sign is the exponent that's on the outside of the parentheses. So from here, I know I have 1 over 3 to the 3rd, x to the negative 2 times 6 is negative negative 2 times 3 is negative 6. Thinking ahead of myself. And n to the third. From here, we know 3 to the third is 27. I'm going to bring this n to the negative 6. Negative 6 only belongs to the x. Sorry, I misspoke again. X to the negative 6. That's the only power I'm going to need to cross the line and change the sign of my exponent. So I'm going to have x to the 6 in my numerator over 27n to the third power. Make sure you box your final answer. And remember, sometimes it's helpful circling everything that you're moving, especially if you are a visual person like me. It really helps us not make a silly mistake, or maybe we our brain's thinking faster than our hand and we just write something down wrong. Okay, so take a moment and finish 10, 11, 13, 14, 16, and 19, and we'll check in as soon as you are ready. So go ahead and finish through 19. Okay, let's take a look at how we did. So taking a look at 10 and 11, and if you just wanted to check your answers really quickly and you don't need to go over them, that is totally fine. Totally fine. So taking a look at 10, that a to the negative third is the only power that needs to cross the line, change the sign. Final answer, b to the fourth over b to the third. B to the fourth over a to the third. Okay. Number 11, notice that this negative 2 is really negative 1 times 2. That negative 2 exponent, its base is not all in negative 2 because we don't have those parentheses. So we know that negative 2 to the negative second is not the same as negative 2 with parentheses to the negative second. Really be aware of that this here is going to end up being a negative, where when we have the parentheses around all negative 2, that will end up being a positive. So really be aware of what is your base. All about that base, Taking a look, we have negative 1 times 2 to the negative second. So this negative 1 stays in the numerator, 2 to the negative second, cross the line, change the sign, and we know 2 to the second is 4. So that's how we get negative 1/4 there. Be careful with that problem. Okay, 13, n to the negative second is the only power that needs to be moved. 4 times 3 is 12. N to the third over n to the second, there will only be one factor of n remaining in the numerator. 12n is your final answer for 13. 14, I did power over powers. Negative 3 times 2 is negative 6. You need to have a positive exponent in your final answer. You cannot leave your answer with a negative exponent. It is not in the simplest form. Taking a look at 16, there was a couple of powers we needed to move around. So I circled them to remind myself, and then it became 2 to the first in the numerator and b to the fourth in the numerator, and the denominator had 6 to the second. We do want to simplify that, and notice that 2 over 36, they're both even, so of course that is 1 over 18, which we final answer is b to the fourth over 18. 17 we did together. In my notes, you'll see I showed a couple different methods just because there's a lot of ways we can use these rules. It's just some are a little more efficient than others. If we take a look at 19, just a little bit of a brain puzzle thinking about this. If you have n to the negative 3 and it's equal to 1 over n to the fifth, when is this true? Well, n to the negative 3 is 1 over n to the third and 1 over n to the fifth here. So if we look at this, plugging in numbers, if n was 1 or negative 1, they are going to be equal to each other. So that's just a fun little puzzle to think about. Okay, well, let's look at my friend Erica. So Erica and Barry are having a little math discussion, just giving some evidence, trying to figure out who's right. So Erica explains that x to the second over x to the second is equal to x to the 2 minus 2. And x to the power 2 minus 2 is x to the 0. And because the exponent is 0, Erica says that, so x squared over x squared is 0. Sounds a little fishy. Well, good thing Barry came along, because Barry disagrees with Erica and says, well, x to the second over x to the second is x times x over x times x. And those factors cancel out, so we get 1. So who's correct? And maybe we talked a little bit about this, I think, before the lesson, and you're right, it's Barry. Barry is correct here. X squared over x squared is 1, which means x to the 0 power is 1. Really nice job. We can think about this applying it because any number over itself is 1. We can also apply our exponent rules like Erica was doing, x to the 0, 2 minus 2 is 0. So the algebraic rule for a 0 exponent is any real non-zero value raised to the 0 power is 1. So, example, a to the 0 is 1 when a does not equal 0. Really important, a cannot be 0 here. You might be wondering why. I'll talk to you about it in a second. Take a look at 22 and circle all that apply. Pause the video, quickly circle all that apply, and we'll go over why or why not. Okay, so the ones that apply, A is true and C is true. 100 to the 0 power is 1. All in negative 7 to the 0 power is 1. Uh-oh, did you pick B? Well, remember, B is negative 1 times 5 to the 0. That exponent of 0 only belongs to the 5. So this is negative 1 times 1, which indeed is negative 1. And 0 to the 0 power is undefined. So if you think about this, remember, we cannot divide by 0. Never give up, never surrender, and never divide by 0. So if you had 0 to the 0 power, well, we can think about that as 0 to the second over 0 to the second. Well, that's 0 times 0 over 0 times 0. You guys, that's 0 over 0. Can you divide by 0? No, it's undefined. So this is undefined. So a little reminder, you can never divide by 0. You can't split something into 0 groups. It just doesn't make sense. Groovy. Okay, so let's get into our last page. So I would like you to look at 23, 24, 25, and 26. No calculators. Go ahead, pause the video, finish those problems, and we're going to go over them in just a second. Okay, let's see how we did. So which is greater? 23, which one is greater? Well, we know that negative 3 to the 0 power is negative 1 times 3 to the 0. Negative 1 times 1, which is negative 1. Where negative 3 to the 0, all in negative 3 to the 0 power is 1. So we know that negative 3 to the 0 power is greater than negative 3, no parentheses, to the 0 power. The parentheses make a difference to what number is the base with an exponent of 0. So taking a look at 24, remember when we order them from least to greatest, we want to list them in the original. Negative 6, no parentheses to the 4th, then negative 6 with parentheses to the negative 4th, negative 6 parentheses to the 0, and negative 6 parentheses to the positive 4 power. This might be like, well, Mrs. Barr, you told me I can't use a calculator. I didn't know what 6 to the 4th power is. Well, all you have to think about is negative 6 raised to a positive 4 is going to be bigger than 1, like way bigger. Negative 6 with parentheses to the 0 is going to be equal to 1. Negative, without parentheses, 6 to the 4th, it's going to be a super big negative number, so it's way less than 1. And negative 6 to the negative 4th power, well, that turns into 1 over 6 to the 4th, so it's 1 over a really big number, so it's a super tiny fraction, but it's still positive. So it's just a little bit less than a little bit less than 1, but still positive. So that's how you can order them from least to greatest. Taking a look at 25 and 26, which you just finished, what we have here, 25, we're all multiplying with the same base. So we can add our exponents. We get a sum of 2. 8 to the second is 64. 26, taking a look here, this exponent of 3 on the outside. I decided to simplify what's on the inside first. I find that a little bit more efficient for me. You could do it either way. You'll end up with the same answer once you simplify completely. So here we get 27x to the 9th, y to the 15th. Good job, mini mathematicians. So taking a look, I'm going to do 29 and 31 with you, and then you're going to finish the rest of the page. So taking a look at 29, what we have here is we have a lot of exponents. So what I'm noticing is I'm going to move all of my powers that have negative exponents that belong to them. And so now I'm just going to move them. So I'll have 10 to the positive 1, k to the positive 3, t to the positive 5. And what's left down there? K to the first. I like writing the exponent of 1. I'm going to bring everything from the denominator that I circled up. This is still 2 to the negative first. It's the exponent on the outside. That changes its sign. And t to the third power. Now I'm going to do a little bit of simplifying. I notice I have k to the third and k to the first. I'm also going to explore this, simplify that. So I'm going to have 2 to the negative second over 10. I'm going to have t to the third over t to the fifth. I'm going to have 1 over k to the fourth power. From here, well, I know 2 to the negative second, I'm going to have to bring that to the denominator because of the negative exponent. So I'm going to have 1 over 2 times 10, and t to the third over t to the fifth. There is 3 factors that will cancel out. I'll have 2 factors left in the denominator. I have 1 over k to the fourth. So my final answer, when I multiply everything together here, oops, I lost my 2. Sorry about that, you guys. Notice 2 to the negative second. This turns into 2 to the second power. Maybe you were yelling at the screen. So 2 to the second is 4. 4 times 10 is 40. Make sure these are in alphabetical order. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. So K is going to go first, K to the fourth, T to the second, all in the denominator over 1. So again, when we are writing our answers, we want our variables to be in alphabetical order, our coefficients or numbers to be in front. Awesome. So that we know is in simplest form. Okay, I'm going to help you with 31, and then you're going to finish the page. So taking a look here at 31. Oh, so we have x to the second to a power and x to the third to a power. So what I'm going to do is I'm going to simplify this power of a power. So remember, this is going to be x to the 2 times n minus 4 over x to the 3 times n plus 1. So I'm going to get x to the 2n minus 8 over x to the 3n plus 3. So now, because we are dividing with the same base, we have a quotient of powers. So we just have to ask ourselves, which exponent is larger? Well, if you take a number, multiply by 2, and subtract 8, that's going to be smaller than if you take that same number, multiply by 3, and add 3. Very interesting. So what we want to note here is that 3n plus 3 is going to be greater than 2n minus 8. Because we always want to ask ourselves, where is the bigger exponent? Where are those leftovers going to be? So we know that this is going to end up being, the leftovers are in the denominator. So this is x to the power of 3n plus 3 minus 2n minus 8. So be careful with that double negative. So this is 1 over x to the 3n minus 2n is n. And 3 minus negative 8 turns into 3 plus 8. So that's right, plus 11. So remember what we talked about with which exponent is larger when you're working on 32. Okay, go ahead and finish the page. Pause the video, finish the page, and we will go over our answers in just a minute. We'll talk about 27, 28, 30, and 32. Okay. So 27 and 28. 27, I moved around just my negative exponents first. So I had all my positive exponents, and then I had a quotient of powers here. I'll have one factor 3 left in the numerator, and a total of 5 factors of n in the denominator. 28, I noticed I moved around. Well, first I split them into fractions with the same bases, and then I moved around my exponents, and I got b to the 5th over a, and then c to the 3rd power. Really nice job. So taking a look at 30 and 31, the only ones we have to go over still. 30 you should have gotten 4, and 32 is b over a to the 4n. So on 30, notice because we are multiplying here, we can cross cancel. X goes into x once and into x once, and you could cross cancel the 2 and the 4 also if you wanted to at that point to get 1/2 to the negative 2nd power, which you could have said that that is 2 over 1 to the positive 2nd power, right, from here, which we just get 2 to the 2nd power, which is 4. Or we could have gone the long way. And 32, I noticed I broke up into the same bases. 7n is greater than 3n, so my leftover exponents are going to be in the denominator, my leftover factors. So 7n minus 3n is 4n, and b to the negative 1st has to come up to the numerator to have a positive exponent. So we have b all over a to the 4n power. And again, if you were going to put that into a dot or on a computer, I would say b and then put a fraction bar, and then I'd put an a, and then I'd put an exponent, a caret, and that's 4n. Perfect. Really good job. No parentheses needed there. Excellent job, mini mathematicians. Great work with all of our exponent properties. I will see you next time. Stay psyched, do your best, be nice to everyone.